In the field of science, the huge mysteries pertaining to what existed prior to the enormous explosion have sparked mixed conversations and fascinated scholars for quite some time. This enormous question tests more than just our ability to decode the universe. It challenges the actual boundaries of human knowledge. Imagine yourself at the brink of existence, examining the colossus of the cosmos, observing and pondering the contents that existed before our universe was imagined. The Big Bang, which established the beginning of all things, including time and space, raises the question, what was there a moment earlier? In the past, there might have been a state of nothingness, a state of calm before the cosmic gathering began. If this is accurate, or perhaps there was something far more frightening that existed before the beginning of time, then our inquiry takes us on a journey beyond the limits of science. Insights into the origins of the universe test our conscious awareness. Physicist Brian Cox is well known for his examination of the marvels of the universe. He suggests that a surprising reality may have existed prior to the massive explosion. He directs us to reconsider our perception of the world and existence. In this investigation, we dissect theories, research, and dazzling insider information that could reveal what happened before everything else. We explore ideas such as self-importance in cosmic growth, quantum alterations, dark energy, and multiverses. The responses we uncover may astound you, but they could also open up new understandings of our place in the universe. Get ready to plunge headlong into a world that goes beyond science and imagination, where the unknown continues to lurk in the shadows, shocking scientists and, at times, even provoking frustration. So, why and what existed prior to the Big Bang? These theories challenge everything we thought we knew. To appreciate what has existed since the beginning of time, we must first carefully examine what the Big Bang truly was. Scientists define it as the moment when the universe, extremely hot and dense, rapidly expanded, initiating the formation of all matter, energy, and innumerable forces. When we examine the night sky, we see evidence of this rapid expansion, with galaxies spreading out in different directions from an early stage. But for what purpose? Why did this happen? The theory of massive expansion suggests that, prior to the Big Bang, the universe was not an empty void or a tranquil space. Instead, it implies that the universe existed in a cold, empty, and unorganized state, much like an enormous vacuum. However, this vacuum was not completely empty. It contained a gigantic amount of energy that fueled the rapid expansion of space itself. This expansion, or inflation, occurred at unimaginable speeds, laying the foundation for everything that followed. Space increased at an extraordinary rate until the speed of expansion slowed, allowing energy to transform into matter, atoms and the forces that constitute the universe as we know it. But what was this energy used for? Why did the universe suddenly expand, and why did it stop? Experts believe that this incredible expansion caused each patch of the universe to undergo its own Big Bang. Imagine a fabric extending infinitely, forming tiny air pockets, each representing a universe, including our own. This idea, called the multiverse theory, suggests that Big Bangs occur endlessly, with infinite universes forming. This perplexing reality challenges our understanding of the cosmos, leaving us to question whether there are alternative explanations. Some theories suggest that before the Big Bang, there was nothingness, speculative yet not entirely real according to current understanding. Even if all energy, radiation, and particles were removed from the universe, true emptiness might still be unattainable. The void in our universe is not completely empty. It is filled with quantum fields, dark energy, and other forces, creating a cosmic tapestry that prevents total inertia. Even in the most barren vacuum, quantum fields continue to exist. A phenomenon known as zero-point energy represents the lowest possible energy state of quantum fields. Even in this state, particles can temporarily appear and vanish, creating a faint reverberation of movement in what should be an empty void. This concept challenges our very notion of emptiness. Scientists now explore whether these fields themselves could have generated particles and matter, potentially giving birth to the universe. Dark energy, an unidentified force driving the universe's rapid expansion, raises another question. Did dark energy exist before the Big Bang? Some theories suggest that the dark energy present today could be a remnant of an earlier energy field, one that existed before our universe even began. Energy seems to point to a huge secret, a force that may have been present in some form prior to the Big Bang. According to some hypotheses, dark energy exists in a much stronger condition and could have managed to contain the inflation stage that led to the rapid growth of the universe. The presence of dark energy indicates that, regardless of whether the universe in which we live was completely devoid of all matter and radiation, this force would keep expanding. This idea leads to an upsetting inquiry. Could dark energy have existed long before the Big Bang and shaped the conditions that led to the beginning of our universe? Could dark energy be the silent architect of inflation or even the actual origin of our universe? As we investigate this possibility, we confront the notion that dark energy is more than just a shaping force of our universe. It may be a key to unlocking the secrets of the multiverse. Another theory proposes a replacement for the Big Bang: cyclic cosmology, which suggests that the universe experiences endless birth-death cycles. In this model, the Big Bang is not a singular event but rather part of an unchanging rhythm, where universes expand, contract, and then regenerate in another cycle. It's possible that our universe was reborn from the remnants of a previous one, following a pattern of continuous expansion and contraction. If true, this would imply that what we consider the beginning was merely a transition, not an absolute origin. Cyclic cosmology raises significant questions about time. It suggests that time itself may be cyclical rather than linear. If this theory holds, it could mean that before the Big Bang there was not nothing, but rather a previous universe that collapsed, giving birth to our current universe. This theory offers a compelling response to the ultimate question of origins, that there is no distinct beginning, and in some way the universe has always existed. Another intriguing concept involves gravitational waves, which could provide clues to previous cosmic events. Gravitational waves from the Big Bang are ripples in spacetime caused by massive cosmic occurrences. If early-stage waves are ever detected, they could offer insights into the universe's infancy, serving as remnants of a past Big Bang. Detecting such waves is one of the most exciting possibilities in modern cosmology, as it could not only confirm details about the Big Bang but also reveal the cosmic state prior to it. As we continue exploring what may have existed before the Big Bang, we push the limits of our understanding, challenging even our most fundamental assumptions about space, time, and existence. One of the most remarkable ideas comes from quantum gravity, which aims to merge quantum mechanics with general relativity. This unification might reveal a single theory for everything, providing insights into pre-Big Bang conditions. According to quantum gravity, time and space are not continuous, smooth entities as we experience them. Instead, they may be composed of granular structures at the microscopic Planck scale, where tiny quantum fluctuations shape the universe in ways we do not yet fully comprehend. From this perspective, what we perceive as the smooth spacetime continuum may have emerged from these shifting quantum fields. This suggests that time itself only materialized from quantum changes, meaning that before the Big Bang, reality may have been entirely different, lacking the concepts of time and space as we understand them. Another possibility is that our universe is part of a vast cosmic landscape filled with potential universes, each with distinct physical characteristics. This idea, based on string theory, suggests that all fundamental particles are actually tiny vibrating strings. Different string configurations correspond to different sets of physical laws. This string landscape implies that our universe may be just one of many, each emerging from its own distinct Big Bang. If true, other universes might have different dimensions, gravity strengths, or even entirely different types of matter. The multiverse theory offers a fascinating explanation for what existed before our Big Bang. Another universe, arranged differently, possibly leading to an endless cycle of creation and destruction. Additionally, some physicists speculate on the role of black holes in shaping the universe. A growing hypothesis suggests that our universe may have formed from the collapse of a black hole in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another cosmos, meaning our Big Bang was simply the birth of a new universe from an ancient black hole. General relativity states that a black hole's singularity is a point where space-time curvature becomes infinite, causing known physical laws to break down. The extreme conditions inside black holes may allow the birth of new universes. This raises the possibility that the Big Bang was merely the emergence of a new reality from the singularity of a long-dead black hole. These concepts force us to reconsider the nature of time itself. Some cosmologists argue that time as we perceive it might not have existed before the Big Bang. If true, then asking what came before the Big Bang might be meaningless because there would be no temporal framework in which to place a before. This idea aligns with quantum fluctuations, where time may have emerged from an initial quantum state, blurring the distinctions between past, present, and future. Cyclic cosmology further complicates this picture. It suggests that the universe undergoes countless cycles of birth, expansion, and collapse. In this model, the Big Bang may not have been a one-time event but rather the most recent bounce in an infinite series of cosmic cycles. These cycles may not always be identical but could vary in different ways, with each iteration of the universe having its own unique physical properties. If this theory is correct, then the universe has no ultimate beginning or end, just an endless sequence of contractions and expansions. Another perspective suggests that before the Big Bang, the universe existed as a dense primordial soup of fundamental particles, quarks, leptons, and bosons, in a high-energy state. At extremely high temperatures and densities, these particles would have interacted in ways that set the stage for the emergence of energy and matter as the universe cooled. Some versions of this theory propose that this primordial state existed within a quantum foam, where particles continuously appeared and disappeared due to quantum uncertainty. Understanding this pre-Big Bang state could provide valuable insights into the origins of our universe. Yet, despite these theories, the mystery of what existed before the Big Bang remains one of the most profound scientific questions. As quantum cosmology and fundamental physics continue to evolve, new hypotheses will emerge, offering increasingly complex and sometimes paradoxical explanations. While we may never fully comprehend what came before the Big Bang, the search for answers will continue to push the boundaries of human curiosity, driving us to explore the unknown edges of existence.